Jason asked me to do a talk titled The Music of Physics, and since I've been writing a book, I keep finding these areas that I'm interested in that don't quite fit in the book, and they always come around to this kind of stuff. So I actually had written about 2/3 of this by the time I started working on it and just didn't realize it. So I went ahead and prepared it, so I'm just going to read this as a paper, and then if you guys can ask questions and comment and give me your feedback. So I'd like to start this talk with a question that I want you all to apply to everything I discuss. If sound is vibration, and vibration causes heat, which releases infrared light, and if at the same time, through the exchange of energy, the fields of gravitation, acoustics, and electromagnetism intersect, and if in all three fields musical ratios are present, does this mean anything? If so, what does it mean? Music is a liquid form of culture, shaping itself to its container. Like water, it gets recycled and reused. It can be frozen, forgotten, and rediscovered years later, like an ice core, holding the secrets of the past in its rapidly melting embrace. Music is a raging flood, plowing through entire generations and rearranging the intellectual landscape. It has the healing power of a sauna and the destructive force of a hurricane. It can be polluted and poisoned, and it can be a shelter during hard times. I've been a musician since I could first sing, playing instruments since I was 5. I studied music at Hampshire College and Berklee School of Music. Since then, I've done nothing but play and teach music professionally. I've shared the stage with some amazing artists, both famous and obscure. I've made records, played with orchestras, and toured in different countries, even recently writing a book called The Magic Music Method on teaching piano. Sometimes my life feels like that scene in the movie Being John Malkovich, when they get off the elevator and they're on the Malkovich floor and everybody is saying, Malkovich, 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 Malkovich. Only in my life it's music, 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 music. If physics is how we describe nature using the language of math, then music is the sound of that language. Sometimes when people make claims about music and physics, it comes in a New Age context of mystery and wonder, involving non-disprovable elements where magic and time travel are right around the corner of whatever scientists haven't quite figured out yet. Then the corner moves and the magic moves with it. We need disprovability to build a more rational, intelligent, efficient, and well-structured world. This is one of the core messages of the new Cosmos series. Speaking of Cosmos, I met Neil deGrasse Tyson recently at a gig. I was hired to play music at a dinner at Vanderbilt's Dyer Observatory where he gave a speech. He was impressive with his charm, with his intellect and philosophy, and his amazing vest with stars on it. Based on meeting him in person, he was wearing the vest. Based on meeting him in person, it strikes me as odd that he was recently quoted, taking a very anti-philosophical tone. He said, and I quote, "What are you doing? Why are you concerning yourself with the meaning of meaning? If you are distracted by your questions so that you can't move forward, you are not being a productive contributor to our understanding of the natural world. And so the scientist knows when to question what is the sound of one hand clapping is a pointless delay in our progress." It's as if he's saying, thanks philosophy, but your job is done here. I'll give him the benefit of the doubt and assume that there is a larger context to his statements. At least I hope there is. The fact remains that when taken at face value, his comments reflect a real problem. Without philosophy, science has no guidance. And just what kind of philosophy is he recommending that we draw? If he's talking about modern academic philosophy, I can see why he might not think it always directly applies to the hard sciences. At the same time, we can't know what kinds of problems the future will hold, and we need all the tools at our disposal to solve them. For that reason, philosophy is important, but I wouldn't stop at academic philosophy. I find it interesting that in the Cosmos series, the more ancient philosophy, embodied in the Hermetic axiom, as above, so below, is either passed over completely or taken literally, to only reflect a kindergarten-level straw man interpretation of its symbolism, instantly discarded as superstition. This reminds me of the allegory of the 3 blind men and the elephant. Each one thought they were touching something different. And of course, none of them realized they were all touching a single thing. They were all touching the elephant. The elephant in this room is not immediately obvious, but hopefully by the end of my talk it will be clear. In order to talk about the music of physics, I need to start by talking about the philosophical foundation for both music and physics. The elephant in the room is the subject of harmony with a capital H. This is a very, very old discipline, one that at different times and in different societies has held together both the arts and the sciences. It's what Buckminster Fuller meant when his definition of synergy. He said, and I quote, "Synergy is the only word in our language that means the behavior of whole systems unpredicted by the separately observed behaviors of any of the system's separate parts, or any subassembly of the system's parts. There is nothing in the chemistry of a toenail that predicts the existence of a human being." I like Fuller's definition. Synergy or harmony is the study of whole systems, in which the whole is somehow greater than the sum of its parts. The philosophical foundation for this can be found in the sevenfold framework of the liberal arts and sciences. These 7 early interdisciplinary studies, which lay at the foundation of the Renaissance and the Enlightenment, are broken into 2 groups, the Trivium and the Quadrivium. The Trivium is grammar, logic, and rhetoric. It must be studied in that order. Grammar is the collection of verified facts and evidence, and the structure of the language used to describe those facts. With grammar, we learn how to listen, how to study, how to inspect. Grammar is more than just subject-object agreement. It is the basis of the empirical method. The next step in the Trivium is logic, the removal of contradiction. Logic is the math behind thought. It is the algebra of language. Once contradiction is removed, the 3rd step is rhetoric, or the art of communication, persuasion, writing, and speaking. I'm using rhetoric right now. You're using grammar to take in my rhetoric, and you're exposing it to your own sense of logic, either agreeing or disagreeing with what I have to say. Rhetoric is the way that the findings of grammar and logic are shared with a larger community. Neil deGrasse Tyson is a master of rhetoric. If the Trivium is the foundation for research, analysis, evidence gathering, and publication, the Quadrivium is what is being studied in the first place, the patterns of nature. The first step is known as number. In this stage, the idea of number or ratio is larger than what we currently think of today. Number is a measure of proportion. This older idea of number is philosophical and includes not just counting, but the personality of every number. To the Pythagoreans and to Plato, as well as the builders of the great temples, monuments, and cathedrals the world over, numbers have identity. They interact with each other like characters in a great drama, creating ratios in their interactions that allow their personalities and meanings to intermingle. The second stage of the Quadrivium is geometry. Geometry can be defined as number in space. When proportions, ratios, and numbers appear visually, they create patterns. The simplest patterns, which follow whole number ratios, have the most powerful psychological effect. Symbolism always uses a certain amount of geometry because of this, and it can be seen in religious and spiritual symbols. The 3rd step of the Quadrivium is music. Music is number in time. I'll say that again, music is number in time. As any musician who understands theory knows, music is the sound of math. As math is the language of physics, all music, every bit of music, is the music of physics. The ratios and proportions of tuning systems have always been related, one way or another, to the concept of number presented here. The 4th step of the Quadrivium is astronomy, number in space and time. Astronomy was required in older times for civil engineering, for the planning of empires, navigation, the planting and harvesting of crops. It was a critical aspect of national security, economics, and war. Astronomical observations were passed down from one generation to the next and encoded in stone monuments that were built like giant clocks to track the music of the sky. In order to have a music of physics, it is necessary to focus on the aspects of physics that can be translated into a musical language. The best place to start looking, based on the Quadrivium, is astronomy. Let's take a look at the music of the spheres and see what it's all about. In ancient times, when the great megalithic monuments such as Stonehenge, the pyramids, and the Temple of the Sun were built, it was not possible to measure beyond 97 to 99% accuracy. The numbers were based on close approximation. Looking at these close approximations reveals underlying harmonic patterns which correlate musical ratios to the celestial patterns that these monuments were symbolically marking. This is similar to how we can use the golden mean to reveal the geometry of the human form, while acknowledging openly that no individual person's body demonstrates the golden mean to 100% accuracy, yet it still exists. We're going to look at three areas that all share the same set of ratios: the overtone series, the whole number ratios of just intonation, and the orbital resonances in the solar system. In the overtone series, if a string is vibrating at a fundamental frequency, for example the note G, there will be a series of notes that sound all at once. These notes are so quiet you can only hear them if you manipulate the string by touching it in different places to silence the louder, lower notes and allow the higher, quieter overtones to emerge. The overtones go up in a very specific order: fundamental, octave, fifth, another octave, major third. Octaves, fourths, and fifths are the most similar in different cultures' music, no matter how differently the tuning systems have evolved. Once you go higher into thirds and beyond, there's more variety. This creates a greater and greater series of culturally different approximations. Rather than a perfect conformity to the overtone series, each different tuning system has its own opinion on how to tune various intervals. This often confuses people into thinking that it's all culturally constructed. That's actually false. The overtone series is not culturally constructed, but what we choose to do with it is. In equal temperament, even fifths are no longer exactly the same as what the overtone series offers. The overtone series then is the perfect ideal form of musical harmony which various tuning systems approximate but never completely reach. Consonant intervals, or pleasing intervals, are octaves, fifths, and major and minor thirds. It's no accident that the loudest, clearest overtones in the overtone series are octaves, fifths, and major thirds. When put together, these notes create a major chord. There are two categories of consonances with this: perfect consonances, unisons, octaves, fifths, and fourths. In music theory, we call these perfect consonants. Power chords, if you like rock music, are perfect consonances. And imperfect consonances, major and minor thirds, major sixths, minor sixths. The ratio is listed here from just intonation and Pythagorean tuning, not equal temperament. Both are relevant here, and whenever you see a musical ratio listed here, it'll either be Pythagorean or just. Because the frequencies have been modified in equal temperament, the music you're familiar with would sound a little out of tune to someone who only knew just intonation. You might be tempted to think, now that we use equal temperament, all that whole number ratio stuff must not matter anymore. Actually, it does matter because of the way the major scale is structured. The chord progressions, the musical harmonies we use today, all have very specific personalities and functions, like individual members of a family. There's a mom, a dad, a sister, a brother, a dog, a 2-chord, a 5-chord, a 6-chord. All of these personalities are based on the overtone series. In order to explain exactly how this works, I need a lot more time. Maybe that'll be the focus of another entire presentation. Those familiar with music theory should know what I mean when I say that the overtone series itself defines a thing called tonal gravity. Consonance and dissonance, whether or not you realize it. It is absolutely not subjective or socially constructed. This is the reason why certain chords create expectations of resolution. This is why we have tension and resolution, and when we don't get what we want, we feel it on a deep level. This is the machine code of the operating system of Western music at the structural level. The user interface of whatever tuning system you happen to choose, of course, is subjective, as whether you like Windows, Linux, or Mac, or something else. In our solar system, a similar phenomenon is taking place, but it's not happening with acoustics. It's happening with gravitational attraction and repulsion. Yet somehow, the same approximate ratios can be found. This observation amazed our ancestors, who called it the music of the spheres. Every celestial body has a different orbit, whether it is a moon, a planet, or something else. Some celestial bodies are locked into patterns called orbital resonances, when two orbiting bodies exert periodic gravitational influence on each other. This happens when the orbital periods are related to each other by a ratio of two small integers. Orbital resonance can either lock into a stable pattern that lasts for millions of years, or actually cause bodies to be ejected from their orbits. When I first heard that many of the orbital resonances trace out musical intervals, I didn't believe it. I took this chart of measurements from Jean Martineau's book on the music of the solar system and checked that the data were correct by comparing them to figures posted online by NASA. I even got out a calculator and did some 5th grade algebra. It turns out that these ratios are correct to between 97 and 99% accuracy. There are many categories of orbital resonance, but only two that we will cover here. First, mean motion orbital resonance is when the orbital periods of two or more celestial bodies create a ratio, such as 2:1 or 3:2. This is explained by the laws of planetary motion, Bode's law, and the equations that govern Lagrangian points, which would be best left for a physicist to explain in detail. The orbits of Pluto and Neptune create a 2:3 ratio, which is a musical perfect fifth. When you do the math, it comes out to 99.199% accuracy. There are some other factors which bring this up to 100% when taken into account, which include the existence of points in space that are defined by the gravity of the different bodies in resonance with one another. These points create nodes, which are similar to the nodes that appear in Chladni diagrams. It's interesting to think of the solar system as a large resonant structure composed of standing waves. Back to Pluto and Neptune, recall that the 2:3 ratio is also the second overtone in the overtone series. The moons of Jupiter create octaves. Ganymede, I hope I'm pronouncing these right, some of these are weird names. You guys can correct me later. Ganymede, Europa, and Io create 1:2 and 2:4 ratios. Again, the exact orbital periods have a margin of error that is made up for when the harmonic nodes created by their mutual gravitation are taken into account. This is a list of the main mean motion orbital resonances in our solar system. They are unisons, octaves, fourths, and fifths. There are no dissonances, such as minor seconds, tritones, or augmented sixths, at least that I could find, although I love the opinions of some of the physicists here, because you may know things I don't know. When two bodies are almost perfectly in resonance, but off by even a very small amount, they are in a near-orbital resonance. They do not exert a periodic gravitational effect that is large enough to lock them in mean motion resonance, but they may appear to be in resonance to the naked eye. In fact, they may have been in mean motion resonance in the past. They may be headed toward it in the future. A perfect example of this is the Venus-Earth resonance that approximates the golden mean ratio. The mean motion orbital resonances have periods of stability that last for millions of years. The approximate ones are either thought to be moving towards it or away from it. It's likely that it takes just as long for the bodies to fall into these stable patterns, predicted by the laws of planetary motion. There are more near-orbital resonances in our solar system than mean motion resonances. The near ones fall into three categories: musical intervals, rhythmic ratios, and what I'd like to call philosophical ratios. The musical intervals represented by near-orbital resonances are all imperfect, consonant intervals. For example, the moons of Pluto, Nix, and Kerberos, did I say that right? I think I said that right. They create a major third. All the common ratios used in rhythm exist in near-orbital resonances. Mars and Venus play triplets with each other. There are roughly 3 orbits of Venus for each orbit of Mars. He's clearly outnumbered here. The philosophical significance of the Earth, Moon, and Sun relationship is demonstrated with the concept of squaring the circle through the use of the ratio 22/7, which approximates pi. This approximation is the foundation for the geometry of the Great Pyramid. Speaking of pyramids earlier. I'm not going to make any claims about aliens, but this is interesting. So this approximation is the foundation for the geometry of the Great Pyramid. which encodes both the golden mean and pi in its architecture. By doing so, it demonstrates the connection between the human form and the measurements of the diameters and circumferences of the Earth and the Moon. These numbers have very high significance to Pythagorean tuning, as A was tuned to 432, and that is harmonically tied to the approximate diameter of the Sun and the Moon. I'll show you that in a minute. We are led to believe that the people who built this monument thought the world was flat. The perfect mean motion orbital resonances of the planets stop at the 2 to 3 ratio, the interval of the fifth or the second overtone, if you still think Pluto is a planet. If you've finally accepted the loss of Pluto, then only perfect resonances of planets are octaves. Beyond this, only moons create perfect resonances. It's interesting that the moons in our solar system, which have much smaller orbits, are the main source of higher resonance. This reminds me of the fact that the most common musical intervals across all tuning systems are octaves, fourths, and fifths. Human culture is quite literally imitating the patterns of nature by doing this, because the only perfect resonances happen to be the most common intervals that have been changed the least from the overtone series. Many of these orbital resonances were only discovered and measured in the last few centuries and create what may seem to be a problem. If the observations of orbital resonance are meaningful to musical theory, how could there be any meaning in resonances that were impossible to detect thousands of years ago, when the basic intervals of music had already been created? After all, most of these moons were invisible to Ptolemy when he was creating just intonation, and he didn't even realize that the Earth went around the Sun. Pythagoras, the father of Western music theory, did not have NASA telescopes. I don't know the answer to this, but I guess that there are laws of nature at work here which govern some of these observations. It might be wise to look at how the overtone series can be applied to gravitation and electromagnetism. Since the laws of nature are consistent, maybe the patterns that evolve in both large and small scales are harmonically related by a mutually shared, deeper, and unseen cause. If you take musical vibrations, oh yeah, you know I didn't go through those. There's a couple, check this out. So the Great Pyramid encodes the relationship of the Earth and the Moon to a high degree of accuracy. And it also happens to create Pythagorean 3, 4, 5 triangles, and it lays perfectly over Da Vinci's square of the circle. So it's interesting. If you take musical vibrations and double the frequencies until the numbers land in the visible light spectrum, it is possible to visualize the higher octaves of sound vibrations as colors. Light and sound are different phenomena, of course, but that doesn't stop us from correlating them for artistic purposes. In fact, the great composer Scriabin invented a light organ for this very purpose that actually played light, way before the iTunes visualizer. This is how art imitates nature. Here's a few quick observations of some strange synchronicities. Taken alone, they could be random, but seen as a group, they may require more explanation than I can personally provide, and I would love to hear the opinions of the scientists on this. The radius of Saturn's orbit is approximately the same as the circumference of Mars's orbit. The circumference of Saturn's orbit is approximately the same as the mean diameter of Neptune's orbit, creating a 1-to-1 ratio. Venus's mean orbit is roughly twice that of Mercury, and Mercury's approximate day is twice as long as its own year. That's an octave. Saturn takes approximately the same number of years to orbit the Sun, 29.46, as the Moon takes in days, 29.5, to complete a lunar phase cycle to 99.864% accuracy. The lunar phase cycle is longer than the 27.3 day long orbit of the Moon. It is the amount of time, 29.5 days, that it takes for the Moon to fully move through all 4 phases. This means that the lunar phase cycle happens a total of approximately 365 times in one Saturn year. If the lunar phase cycles were thought of as a lunar day, Saturn's year would be approximately 365 lunar days in length, to a level of accuracy that is within 1/100th of the percentage of difference between our own 365 day year and the true 365.25 day year. So that's kind of strange. The lunar year is 354 Earth days. The synod of Jupiter, or the kiss of Jupiter, when the orbits line up with Earth, is 399 days. Hold on, there we go. This creates a resonance which reduces down to the ratio of 8 to 9, and that ratio is the Pythagorean whole step. Somebody please explain that to me. The lunar year is 354 days. I had so much fun making this presentation because, sorry. It's like endless amounts of information. For a musician, this is a lot of fun. The lunar year is 354 days. The synod of Saturn, or the kiss of Saturn, where the orbits line up with Earth, is 378 days. This creates a resonance which reduces down to the ratio of 15 to 16, the Pythagorean half step. This brings up another interesting point. The patterns of music theory don't stop at orbital resonances. They reflect nature on many other levels, mostly related to how we measure time. So, there are 7 notes in every major and minor scale. There are 7 white keys on the piano. There are 7 classical modes, and there's evidence that they may all go all the way back to Sumeria. There are 7 days in a week, 7 classical planets, which correspond to those days, and which correspond to the 7 liberal arts and sciences. There are also many other 7s, too many to mention. There are 12 notes to choose from. There's 12 hours on a clock. There's 12 months in a year. There's 12 signs in the zodiac. 12 tribes of Israel, 12 apostles, and of course, most importantly, 12 Cylon models in Battlestar Galactica. There are 24 major and minor keys, which correspond to the 24 hours in a day. Half of the keys are major or light, like 12 hours of daytime. Half of the keys are minor or dark, like the 12 hours of nighttime. And I use this in my music lessons to teach theory. So, whether or not every single thing I'm telling you here is exactly, perfectly, scientifically accurate, and I want to know what's wrong so I can fix it, by the way. These are mnemonic memory devices. This is a way of memorizing theory, and I don't think it's an accident that they line up. So, there are 60 seconds in a minute, and the middle of the range of the average resting heart rate is around 60 beats per minute. It can go from 40 to 100 for a healthy person. 60 is kind of in the middle. There's a little controversy over whether that's exactly right, but it's interesting to think about. That's 1 beat per second. That's 120 beats a minute, doubled, which is the most common musical tempo. The limit of mental processing power for most people is around 60 bits of information per second, and the electrical grid is operating at alternating current of 60 cycles per second. So once again, we're seeing all these things converge, and it doesn't mean causality. Of course, correlation does not mean causality, but it's worth looking at. 60 degrees is also the Triforce from The Legend of Zelda. So. There are 72 basic hand positions when the 24 major and minor chords are played, each of them in root position, first inversion and second inversion. Another way that music is imitating physics is that the Earth's precession moves 1 degree every 72 years, which is why it takes 2,160 years to move through 1 sign of the zodiac. There are 72 basic Indian scales on the top left. They actually probably did that on purpose. There's evidence to suggest that they were aware of precession a very long time ago in India, and that the people that created Vedic astrology were also the people that created Indian music theory. So every 24 hours, all 72 of these scales get played. Can have a time in the day where they're played, 20-minute intervals. It's South Indian Carnatic music. So 432, okay, now this one's a fun one, because there's a lot of controversy over this. People want to tune everything to 432. 432 is the frequency assigned to A by Pythagoras. It is one of the most interesting older tunings for A. Instruments can be tuned to 432 whether or not they're equal tempered. A lot of controversy surrounds the idea of returning to this tuning. So there's some other things about 432 that are worth looking at. Jupiter takes roughly 4,320 days to orbit to the Sun. Mars is close to 4,320 miles in diameter. 432 is almost but not quite the square root of the speed of light, to 99.666% accuracy. People who take this literally often think they've discovered magic. Really, they have discovered philosophically relevant approximations. Without this kind of thinking, we would not have physics, because no one would have come up with the first hypothesis worth testing. It's not about choosing creativity over intellect or vice versa. So go ahead and tune to 440. A216 is an octave below 432. The moon is approximately 2,160 miles in diameter. The Earth's meridian circumference is approximately 21,600 nautical miles. Each astrological age is 2,160 years long. 12 of these cycles create a great year. Let's drop an octave lower. 108 is the number of the moon. The moon's radius is 1,080 miles. Is 1,080 miles. The distance between the Earth and the Sun is approximately 108 times the diameter of the Sun. The diameter of the Sun is approximately 108 times the diameter of the Earth. 98.925% accuracy. Again, not 100, but philosophically very interesting. The average distance between the Earth and the Moon is 108 times the diameter of the Moon. There's a list of other interesting coincidences, but I'm going to skip forward a little bit because we're running over. So, well, I got to talk about 864. Okay, so it takes the Earth 86,400 seconds to spin once on its axis, creating the familiar 24-hour day. The Sun is approximately, not exactly, but approximately 864,000 miles across. The diameter of Jupiter is approximately 86,400 miles across, to 99.446% accuracy. 864 divided in half is 432, the original pitch that Pythagoras, the father of music theory and geometry, assigned to A. Thus, the note A in Pythagorean tuning is the approximate diameter of the Sun. It harmonically ties the approximate diameter of the Sun and the rotation speed of Earth together. I think that's kind of strange. The standard 24-hour day broken into 2 periods of light and dark, lasting for an average of 12 hours each, is how we currently measure time. We call it a clock. When I teach music theory, I call it the clock of fifths. It also happens to match these basic harmonies. Since the circle of fifths is like a clock, it's interesting to see what happens when you put in all 60 seconds. The earliest example I know of this was given to my teacher, Yusef Latif, great saxophone and reed player and flute player, by John Coltrane. Another teacher of mine, Reggie Wooten, decoded the diagram for me. An interesting thing happens when you connect all 5 instances of the same note. For example, C on this diagram. The symbol of the Pythagorean school, which is the 5-pointed star containing the golden mean, the geometry of the human body, and the pattern traced in the sky every 8 years by Venus, appears. Right there on the most common diagram in all of music theory, if you know what to look for. Music theory, which was invented by Pythagoras. Let's take a step back now and look at the bigger picture. Both literally and figuratively, music is a reflection of the solar system and the collective unconscious of the culture that creates it. It is not a perfect reflection, but rather it is an approximation. And in this way, it reveals hidden correspondences and harmonies between seemingly separate fields. The resonance patterns of the overtone series also happen to be frozen into the musical geometry of ancient stone temples and monuments. These structures were built by scientists and astronomers to follow the movements of the heavenly bodies. They traced the ratios and proportions of both music and physics in stone clocks whose gears were turned by the rotation of the Earth itself, and whose hands pointed to clock faces written in the constellations. These celestial patterns were remembered with myths and allegories, thus backing them up in the cloud of the collective memory of humanity. Long after the people who built the temples, their writings and their organizations had turned to dust. This mythological hard drive, used to store data inside of coded allegory, was taken literally at times and has a lot of bad blocks and data corruption. And we have inherited the ruins. It is up to us to decode them and put the pieces back together and recover what we can. Rather than discarding this, we should be investigating it. The path of intuitively guided empirical study is something that artists, musicians, writers, and scientists share. It's what created the Renaissance. Some of us are more into proving and disproving things than others, but the foundation is the same, a strong desire to understand what the world is made of, and to participate in the remaking of that world into something more interesting, more efficient, more creative, and more beautiful. Musicians who play with sounds to come up with recipes and combinations of notes, chords, and scales are very similar to scientists who conduct experiments. The creative process is alive and well in both fields. So I'm going to ask this again. If sound is vibration, and vibration causes heat, which releases infrared light, and if at the same time, through the exchange of energy, the fields of gravitation, acoustics, and electromagnetism intersect, and if all these three fields have present musical ratios, does this mean anything? If so, what does it mean? I would argue that it means that we are a part of the whole system, which is greater than the sum of its parts. What we are calling reality is a harmonic system, a resonant structure within which many different kinds of overtone series intermingle on large and small timescales to produce cycles within cycles that we call consciousness and reality. And I would argue that it is disprovable and thus not subject to superstition. We need philosophy to really understand this. Philosophy is what we use to inoculate ourselves against shattered, narrow thinking. Philosophy is what allows the blind man touching the elephant to actually see the whole elephant. If you were to take a chainsaw and cut this elephant into separate pieces, it would no longer be a whole greater than the sum of its parts. The study of harmony puts the pieces back together, allowing quantitative measurements to sit right next to qualitative philosophical ideas. This is exactly the kind of effect that music has on human consciousness. Allowing these parts of a whole to come back together is what gave us the Renaissance and the Enlightenment. Separating the parts of this elephant has given us the scientific and industrial revolution. And putting them back together again, without falling into superstition again or logical fallacy, should be a critical part of how we will navigate the future, assuming we survive this infancy of our modern world. Thank you.